Awesome. Let's get started. So if you guys have questions as usual, just add them in the chat. Like I'll pick them up as I go. Yeah, today is going to be a great session to be looking into fine tuning. So the idea is like how can you sort of customize like ChatGPT for your sort of needs. So it's slightly different to prompting, what you're looking at today. It's so fine-tuning, if you guys have come across that, is basically you change the model weights in a way that represent your problem. So you can get the model to sort of work in behave in a certain way. So if you have specific sort of information that you want the model to learn, you can sort of get that sort of fine-tuned for that your use case. There are so many use cases of fine-tuning. And yeah, we're gonna look at like different types of fine-tuning and then figure out like when to pick fine-tuning and which type of sort of fine-tuning methods to use. So this is gonna be, yeah, super excited for this one. Um, so for today's agenda, we're going to look into like what is model fine-tuning and variations of model fine-tuning on OpenAI. So there are like quite a few variations like supervised fine-tuning, SFT, vision fine-tuning, which is for vision models, direct preference optimization, DPO, which is widely used. For example, even I think DeepSeek sort of fine tuning, they use this method, and reinforcement fine tuning, which is used in quite a very high stake environment like medical, legal, so those kind of domains use like reinforcement fine tuning. And we look into like, yeah, fine tuning versus prompt engineering, what are the benefits, and when to pick which when to pick fine tuning versus prompt engineering, and then sort of data set preparation that's needed to sort of run a fine tuning job, and how you can sort of do that on OpenAI and sort of using that fine-tuned model. So we'll do a sort of a demo, but the issue with fine-tuning is like to do a really good fine-tuning, it takes a bit of time. But I'll do with a small data set and show you like how the model behavior changes, but it may not have the best performance you want. We want to like run it for a couple of hours, like or maybe overnight and with more data. So that's gonna like cost us as well as like takes a bit of time. So because of that, like we'll do a very small test, but you can sort of, depending on your use case, you can pick and choose how to fine tune. So what is fine tuning? So the idea here is like you generally we sort of if you write some sort of a application using ChatGPT, like with the APIs, you would normally use the sort of the vanilla model, which is like it's the base model that they have, whether it's 3.5 or 0. There are no changes to that. It's the same weight that's being used across the world. So it's not customized for your use case. How you customize it for your use case is using system prompts or prompt engineering. So you sort of give the right information there and sort of try to get something back. But you can fine tune these models. For example, the GPT-4o 3.5, you can sort of get a customized version of that model with your dataset and sort of have that available for you to do your own um, sort of workflows. It's going to be quite useful. So for example, some use case would be customer support bot sort of answering about your company's products, that it also can have the same the brand sort of preference, like branding, the narrative structure that you want it to have. You can have these kind of examples built in to the model. And for example, another one could be like a financial AI assistant analyzing your sort of specific Bloomberg datasets. So you can sort of use that to create like a custom model for you. And then legal summarizing models, which you need to have like a very let's say a model that is trained on criminal cases, so you can sort of get like a very specific data set and get it to fine tune one of the versions of OpenAI models. And the model will also now have expertise. Given that you create the data set really well, you have the expertise with legal knowledge to answer your questions. So another use case is that like this is quite valuable. Like let's say if you have like a customer facing sort of a chatbot that you've developed with um, using one of the OpenAI models. So if you want it to have like a specific type of um, um, style of communication, you can get the model to you can fine tune the model, and across your sort of applications, you'll be using a fine tune model. So general flow is that you get a base GPT model and create a custom data set and fine tune it using OpenAI infrastructure, and you get a sort of fine tuned model, and you can use that. Um, so it's important to understand like what's the difference between sort of prompt engineering, that's what we've done in the past, versus fine tuning. So for prompt engineering, there's no like additional like setup. You just call the API. But for fine tuning, you need like label data, and you need to run a sort of a training run to get a customized model. Cost wise, prompt engineering, you only pay for the usage of the model, and for fine tuning, you pay for training and then you pay for usage. It's important to note that the cost will be less this time because you don't have to like always send the system prompts, etc., to the model. So relatively cheap compared to just using prompt engineering. So consistency wise, so it changes based on the prompt, and the fine tuning wise, the model sort of stays consistent. But I mean, there are caveats around that. But generally, if you fine tune for a specific use case, that is static for that sort of training, the snapshot of that model's training run. When to use, I think it's a broader question, but like for now, like it's easier to sort of separate them. For example, if you get like one-off sort of interaction with the model and you have like varied tasks, um, so that's where you use prompt engineering, but you can sort of push prompt engineering to the nth level and get what fine tuning is doing, but it has a lot of sort of manual management. But fine tuning, on the other hand side, you can have like domain specific knowledge, brand specific tasks. You can sort of like get the model to have that inbuilt. So it's the variability is less. Some two examples would be like, okay, summarize a specific report. Like if you just chat with your ChatGPT, that's one example, and you can give some guidelines there. But like, if you have like some interaction that is always has a brand tone, so then it's best to have like a fine-tuned model. So it depends on your use case, when to use which. So the next step is like to look at like different types of like fine-tuning models, variations on OpenAI. So OpenAI currently provides like four variations. Like one is supervised fine-tuning, vision fine-tuning, direct preference optimization (DPO), reinforcement fine-tuning (RFT). So I'll sort of go into detail in a bit, but the idea here is like so the vision fine-tuning is just for sort of image-based sort of fine-tuning, but the rest like you can use it for like multimodal and text. So which is only for sort of text-based, or depending on the model that you pick, you need to like pick the data set that is sort of geared towards that fine-tuning. So we'll only talk about text here for now. So the data set that we use will be text and the output will be text. And then like let's look at different types of the go into detail of each type of fine-tuning model. Just checking if there are questions in the chat. Meantime. Okay, no questions so far. Like, yeah, feel free to add questions. Like, could be, yeah. So supervised fine-tuning, which is short form for SFT. So the idea here is that you sort of create using humans, or like you find the ground truth and create a set of like given a prompt, what's the expected sort of output. So for example, in this example, you say translate I love AI to French. So response would be I don't know French, like it would be something like this. Um, so so the idea is like you create pairs of like input and expected output, so the ground truth, and you create like relatively massive data set, and you use that data set to sort of fine tune the GPT. So if it's a classification problem, for example, if you want like, let's say, classify spam versus non-spam emails, you can create, okay, this is a spam email and this is not a spam email, the output. You can sort of create this like data set. Translations, if you need consistent structured outputs like JSON, and getting like instruction following sort of bots. So given a question, what's the right answer for that? So you can sort of create these kind of data sets and sort of fine tune the model. So the idea here is that the 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 humans would create like a for a question expected output and use that to sort of fine tune. It's like um, normal sort of ML, like fine tune, like training a model, but we can do with OpenAI models. So that's the differentiator here. The next one is like vision fine tuning. So the idea is like for a given image, you'll have a question and you get like a response, like a label response. So image classification problems would benefit from this approach. So one good example here is like, let's say you have a sort of X-ray chest scan, and the prompt would be, "What do you see in this?" and response would be signs of pneumonia. So likewise, for different kinds of image recognition tasks, you can create these kind of vision data sets and sort of train that and get a fine-tuned model to handle, let's say, X-ray, like an AI bot that can sort of handle X-ray sort of questions on X-rays, so it can sort of tell what's the issue with X-ray. So if you have like a really good data set, very easily you can fine tune um, and like get a customized model for you, and like OpenAI will handle the infrastructure side of things, and then you just pay for the cost of tokens moving forward. So the idea here is like, given that you have sort of label data, image data, you can sort of train a model for you. The third one is direct preference optimization. So this you may have seen if you're using ChatGPT. Sometimes it puts out like two answers. So the idea is that the LLM would learn like for a question, it will try to generate two answers and will tell what is the best or the preferred answer. Um, so and so the with that feedback, model is able to sort of pick for a given question, like what's the best answer and what is not the preferred answer. So you use that to optimize the model, and that's what happens on a high level. I mean, we can go into detail later, but the idea is that the model understand what is good versus bad response, and it's a binary sort of feedback that we give, and based on that, model will sort of re-update the weights and have the mental model for the model to properly give outputs expected by the user, the person who actually fine-tune the model. The last version is reinforcement fine-tuning, RFT. So this is basically used by, as I said, like relatively complex domains, like whether it's like medical related questions, law related questions, finance, which needs like very specific answers. So what you do is like is a slight variation from DPO, what we discussed earlier. So the idea here is that for a given question, let's say you get different kinds of answers, and you score those answers based on a score. Like for example, if the answer is perfect, you get it like one, which is like out of one. If it's vague, zero point 0.5. If it is bad, 0.0. So likewise, you can um, rate the answers in a way, and so the model has more data to learn, and in that way, it can sort of uh, get get to a much more like a fine-tuned model much faster, and it will be sort of targeted to that specific domain that you're looking at. So it's a reward-based training, and you need like sort of expert human labelers, human evaluators to sort of rate these answers. So you need to have the setup. Um, the data set needs to represent these kind of data format so that you can sort of fine tune that. So that's the high level, like what sort of fine tuning methods that you have. But yeah, so it's depends on the scenario, which version that you need to pick. But yeah. Then I want to go into how we would train like a model on OpenAI side. I'll sort of show you in a demo as well, but on a high level, what you do is like you prepare a data set, like you need a clean and structured data set in the format of JSONL. I'm not sure if I'm pronouncing it right, but the idea is like you structure it in a way that can be consumed by the fine-tuning pipeline, and you need to have it in the JSONL format. and then you upload it. You have two choices to do this. Like one is via CLI, command line interface, or you can sort of log into the dashboard and try to like manually run it. It's the same process, but like relatively easy if you run it on via your CLI. And then after the data is, so when you first upload the data, to validate if the structure is correct for a given type of fine tuning, and then you create a fine tuning job. So you specify what's the base model that you want to fine tune and start the training. So you can define different kinds of configuration, the number of iteration that you want to run, and there are a few configuration that you can change with this fine-tune model. We'll sort of use the standard guidelines for us, and then sort of try to train a model. And then you get a model with a custom model ID for you to be used via API. And whenever you sort of call that model, it will be um, dedicated for you, and you can sort of like use that to sort of call get the expected response, and it will be dedicated for your use case. So this is like the general sort of workflow, how you would train a fine-tune GPT model. Yeah. So the dataset format, as I mentioned earlier, for you to like fine tune a model, you need to have specific, the output needs to, dataset needs to have a specific format. So if you are training for a prompt completion, it needs to have a structure like this. So prompt, the translate hello, the completion should look like this, output should look like this. If it is a chat message, you'll have system prompt, user question, and what the assistant's supposed to send. So you'll have like a data set like that, and not just one example, like let's say thousands of examples in the JSONL format, and you need to upload that to OpenAI. Sorry, it's so there are some like best practices when you create data set, which is quite important. So the idea here is always quality over quantity. So you need to like make sure you have around 1,000 high quality data set examples, and then you need to um, check if it is in the right format. At the same time, the style, like if it's the same style that you want it to behave. Like for example, if you are like say customer facing chatbot, and you need to make sure that the company's style of communication is in that data set. So that's the second sort of important part, not just the number of quality examples, but also the data within the data set, make sure that we have it in the structure that we want. So you need to carefully go through each examples with people who control the narrative style of your sort of problem, and then sort of get it into um, like a finalized data set. And also, it's important that you try to cover like different kinds of use cases. Let's say, not like obviously the let's say if it's a chatbot that asks questions regarding a product, you need to have like all the types of questions people may ask and the answers to them. But also good to like have different edge cases as well, so that the models sort of understand how to update that. So this is like a general command that you can run, given that you have a data set. You can run this to sort of upload the data set, and then sort of it will start the fine-tuning model, start the fine-tuning process. But I'll show that in the code in a bit. So after this is done, like after the model run is finished, you'll have unique model. So for example, let's say your company, you need to add, like whatever the sort of the company that you have, that the your OpenAI company name, like the profile name, and you'll have a string like this, the data that it was trained on, the company name, and the base model. So you need to refer to this, and this way the OpenAI will know to send this query to that sort of fine-tuned model, and you get a response, and you can sort of just interact the way you interact with, um, and so yeah, so that's how you sort of use the fine-tuning model in your sort of workflow. So yeah, I'm gonna try and see if we can sort of run a fine-tuning run. But in the meantime, like if you guys have questions, feel free to ask them. I can take a couple of questions.
Yeah, okay, just one question, Akshay.
Yeah. What do you mean there are no question answer? Like if they're like let's say if it's in the FAQ, I mean you can like let's say if you have some sort of a
Hmm.
so I think so like what's the size of this data set? Like is it like massive?
It's not like.
Yeah, in this use case, like fine tuning might not be the use like the best
Hmm.
scenario. Like for in this case, might be that using like a RAG solution would be good, where you sort
Hmm.
of all this to like a vector database, and like depending on the
Hmm.
question, the model will
Hmm.
pick kind of information, and then
Yeah.
sort of send that to the LLM. So I think that's so yeah, you have to pick and choose like when to use fine tuning.
Yeah.
This is like given that you have like sort of label data that you can sort of
Right. So
ideally.
it's.
Yeah, so I think like yeah, so I think like I mean I need to like check the problem really well to give
Hmm.
a like final answer, but
Okay.
what you shared, I feel like that might be the best way. Yeah.
Right. Got it. Cool. Okay.
Yeah.
Thanks.
Cool. Let
I
me
got
no, not necessarily. So those kind of like configurations comes like when it comes to when you make the OpenAI call. So those are like configurations that you have when you want to
mhm.
control the output of the LLM. So depending on the level of variability of the outputs, so that's where I sort of fit in. So fine tuning in our use case, what you're trying to say is like given like we have a data set, like a good data set that uh, that sort of defines how our model should behave. So we can sort of use that data set to train the model, like get the GPT model as it is, and sort of infuse that data back into the like a variation of the GPT model that we can sort of always use. So you don't have to like change that as we go. So that's like so the top key those configurations are on our code side. We change that, but this would be on the OpenAI side. We get a version of like a branch, like get a model and get a branch of that model and like fine tune that. So you have a snapshot of that model with your sort of specific custom data embedded in their weights. So you can use that as you see fit. So that's the difference. So does that make sense, Bernard?
Made
Yeah,
like
that's
adjust.
different. Yeah, that's different. Like so that's regarding like how you sort of like create the OpenAI calls, and this is regarding how you can sort of find, like get a version of a model with that.
Oh, that's right. Okay.
Yeah, yeah, yeah. Cool. So so I think like I have a sample here that I've used to run. So I will sort of I will first like show that, and if it time permits, I'll do something from scratch. So the idea here is you need to first have a data set. So let's say so this is like the data set that I have. Um, looks like this. It's not the best way to show this. But the idea is, let me try to get like one sample row here. Um, so yeah, so you would have like so these are like how like if you interact with the chatbot, you may have like a data set like this. So there's a system prompt sort of explaining um, like you are a tech ops customer service assistant, always be empathetic, provide specific solutions. So you have like this sort of system prompt, and then user would come and sort of ask this question, say, okay, my laptop won't turn on, and then this is the expected output, the assistant's response. Like, I understand how frustrating it must be when your laptop won't turn on. So you have sort of a specific answer for this. Like if imagine like a FAQ. So you have like a data set, but it also may have very specific information that is customized for your sort of product or the company. So you can have these kind of pairs like this, and you'll have like this sort of training set. So I'll try to do is like try to run train a model using so the CLI and get it to um, create a model that is like very specific to ours. So I have sort of set up my sort of virtual environment. Sorry, um, I don't need this actually. I also don't need this. I'll leave this. That's fine. So this just created the data set is fine. So this is the script for like fine tuning this. So what it does is generally, so I'll go through each step. You first sort of upload the data, so it will verify. So we have training data. JSONL, and you sort of upload that. So if there's an issue, it will sort of throw out an error. In our case, like I mean, I've formatted that in a way that it shouldn't sort of throw an error. And then what you do is like start the fine tuning. And it will sort of, we need to define like what's our base model and what's the training file sort of ID, which we get from this file response. Like we get a response ID back. Looking at the name of the data set on OpenAI side, you connect that here and you can sort of start training run. So I think like you can set the hyperparameters like so this is like a traditional ML sort of fine tuning like right. So like you need to define like deep if you guys have done deep learning. So you need to define like the number of epochs, which is like the number of iterations that it needs to run. Like if you need like I mean if you need to like maintain like generate a model that is much more so like better, we need to sort of increase these epochs like so it runs a lot more longer and until it hits like a really good threshold for accuracy. But we set it for 1, so that means it will run very quickly, so that means the accuracy might not be good. And then we'll wait like until this job is complete. It checks every sort of 30 milliseconds and sort of get an update when this is complete. I mean, this is not necessarily just to show that this is working. And after that, we need to check if this model's output is different to ours. So for that, um, I've created this set of questions. These are like the questions that we want to ask the models, but we're also trying with like 2 different models. The existing like standard model, which I call the vanilla GPT, which is without any sort of different like without any fine tuning, and we also like try the fine tuning model as well. So, but before that, I'll go into this and I'll try to run like training run. I'll ask you, can you start file tuning run anyhow. There's the settings. Well, and also add the fine tuning model just to make sure that it understands that it's run. But I'll see what it can do. Yeah, so it sort of figured out like okay, because we already have the code for this. What it's trying to do is like execute this. Seems to be an error. Yeah, wasn't logged in for the environment, so it logged in. The environment should be fine. And the next step is like as you can see, is uploading the training data, starting the fine tuning job as well. And then this is a job ID. So if I go to OpenAI, I will see this is running. Currently it says it's validating files. So I'll try to load this. So if I come here, like, so this is my sort of OpenAI dashboard. And if I come to fine tuning, you can see like there are like fine-tuned jobs that I've done in the past. So this is the current run, which is running. So you can see it's still validating the files, making sure the data set is okay. And this is the name of the training data JSONL, which you uploaded. So if you open it, you might be able to, yeah, it's not in a vector data store, it's like is as it is, but we can see like different types of data sets I've uploaded here. And in the fine tuning, still it's validating. Yeah, it may take a bit of time, but if it takes time, I'll show using one of the examples. And you can see like other hyperparameters set, right? The epochs, which is the number of iterations we need it to run. LR multiplier, seed value is just a random number that's given for us to reproduce the run if needed. So, and then the batch size. So we can change all this, but we're just taking as it is. And this is the base model that's been used. And so it was validated. So files are validated, moving job to queued state, which means we're pushing it to be start a fine-tuning model. So how OpenAI does is like it sort of picks its job and it will use the data and it will look at existing so they have GPU clusters that distribute across the world, right? So they check what's the best, like if there are idle GPU clusters that can run this, and so they have an algorithm to like pick this depending on the distance. Like for example, I'm based in the UK. From the UK, like what's the closest for me? And also look at the idle state, if there's the idle state, because there are quite a few costs that you need to look at this, right? Like for example, obviously there's a fine tuning cost, but also you need to look at like the transfer cost. For example, they might, if it's a bigger data set, like in this case it doesn't matter, but if it's a bigger data set, they need to move that data set to that GPU cluster, so that's a cost as well, and train that and get it back. So that's another cost that they're looking at, the data transfer cost. So like they have algorithm for this, and based on that they pick the cheapest model, the model GPU cluster to get this run going. So based on that, they'll start the run. Now it's running, and we might we might see some metrics in a bit to show. But on our side, it says okay, state is running, because we are just every 30 minutes, 30 seconds, I think. We are just checking the status of this run, and we'll get like okay, status is running. In the meantime, I can show like a previous run, how it may look like. So this is a failed run, by the way. So you can see successful runs, failed runs. But this run, I'll tell you why this was failed. So the issue was like yeah, so it didn't have enough examples. So I need to have at least 10 examples. So it was like a smaller data set. So because it's a rejected, so it's not going to work. But so yeah, so it does a really good job of checking this. Now it's still running. So now we can see just like the loss log. I mean, actually you might know this already. The loss function, the accuracy. So you sort of keep track of that, and looking at different sort of step, you get like the the training loss, and it's trying to reduce it, and also the accuracy as well. So but it's evaluating the result and try to sort of reduce the cost, like the error rate as much as possible. But I'll let this run. I think we should get uh, to a reasonably okay level very soon. So you can get the log version of this chart. But by the way, so now the train run is finished. So new fine-tuned model is created. This is a very small run. So in practical scenarios, it will take a lot more longer. And then they're sort of evaluating against their usage policies. If the data, like the data that I've used is like some sort of violates like talks, like it's like it should be used in approved use cases, can't have explicit content like hate messages, things like that. So they're just checking that, checking the model for that. Um, yeah, I will soon see that, like those checks. But you can also see each step, right? So like initially training loss is 2.21, 1.7, so it's reducing. So it's stopped at like 10 steps, which is, I mean, we need to do more, but ideally, I mean, it's fine. So yeah, still this is not finished, but it's still running. In the meantime, I can show like something that was finished here. So you will see, so generally the loss would go down a lot more. And you can also see these moderation checks, which I mentioned earlier. So the model is checked for harassment, hate, like propaganda sensitive. So it needs to like pass these checks at least for us to use the model. So we can't like add anything bad and like train something. If you want to do something like that, you need to get like open source model like Llama and like play around with your own sort of environment. If you want to try something, which is, I mean, obviously don't do something illegal, but like if you play around with the different kinds of use cases, which may not be um, sort of granted like approved by OpenAI, you just need to train it on your own GPU cluster, yeah, separately. So this is what I mentioned earlier. It's like the URL of the model would be this. Like in the past, it would be like GPT 3.5 Turbo and like the version of this. But now you'd have like a prefix FT, and then your company name, and then yeah, your profile name, and then the tag that's based on the date, time, stamp. So I'll let this run, and we'll use this model just to show an example how this might work. I'll sort of skip this, sort of interrupt. So the model will still run. So then I want to like try and run this with the sort of the example, like sort of demo that I want to try and see. Like, so this what it does is like it will sort of compare the usage of like a normal model versus like a fine-tuned model. So we have the model ID here, which shows the same ID we saw here. If you can see, it's the same ID here. So it's the same ID. And you have a system message just to apart from that, there's no any other sort of information that you're providing. I'll ask no, GPT model and the fine-tuned model. So the idea is you can give the same questions and sort of get to compare the expected how those two scenarios would vary. So I don't expect this to be like radically different, but there might be scenarios that we'll see like the different the fine-tuning aspect of the data set. So and it will also sort of analyze this. So yeah, so if we look at like I mean I can look at one of the examples. So you get the vanilla response, which is the normal model, and then you get the fine-tuned model. So I'll just look at one of the examples just to show like how it may look like. Yeah, so let's say customer says my laptop won't turn on, like, so the normal response is like yeah, very bland sort of answer. It gives sort of steps to sort of get the output. But in a fine-tuned model, it's very empathetic. Sorry, I'm scrolling this. I need to go to the scenario to show that. So yeah, the fine-tuned model, I'm so sorry to hear that you're experiencing issues with your laptop. So it's much more empathetic, because if you train the model to be empathetic, so if you have a certain way of like, if you want to be playful, you can have that sort of like the model sort of trained on that. So second question, so the first one is like, what's the question? Customer says, I want to return this product, and I'm sorry to hear that. So it's just like generic answer. And but the fine-tuned model has has set of instructions, which was like, okay, you can drop the package off at any UPS location or request to pick up at your home. So you have sort of instruction that you already know that works. So the model will actually will reply with those instructions because it's fine-tuned on those questions. So this is how it will work, and you need like large amounts of data for this to like have like a really good outcome. But this is the normal step. It's relatively simple to train this. You just need to create the data set, check the data set that it is correct, and then sort of update that. Yeah, and this is like how we sort of fine-tune a model and use that. I'm also aware of the time. Got a couple more slides to go through. In the meantime, if you guys have questions, feel free to add them in the chat. So this is like the cost for training. I want to like quickly go through. I mean, GPT 3.0 Turbo was GPT 4 Mini, which is slightly expensive. And the time to train, like let's say if you have 1,000 examples, this would be the time it takes, like 30 minutes for GPT 4 Mini, depending on the number of epochs as well. Like a good training run take 2 to 5 hours. Yeah, there's like depending on the model, it sort of differentiates. The common pitfalls, like you had to sort of consider when you're doing this like training is like obviously using too little data, and overfitting, which is like it will like fit to the data set. So you have to have very diverse data sets and also tweak the parameters in a way that it would sort of avoid overfitting, like regularization, things like that, so that you're using like normal model training steps. You need to maintain, like check those to make sure that you don't overfit. And garbage in, garbage out, right? So the idea is that you need to have like really good data, it's curated, so that you can sort of fine tune the model in the way that you expect it to behave. And the other thing is like evaluation set. We'll do a separate session on evaluation sets, but the idea is that you need to have an evaluation mechanism to check, okay, now you have changed the model. Does that work for you? So you need to have sort of ground truth examples to check that against the new model's output to see if that sort of improved it. So that's why you need the eval suit, which is like a regression test to check after the model is improved, has that improved the behavior? So you need that to sort of make sure that the model has improved. Obviously, there are alternatives to fine tuning. Prompt engineering, cheap, fast, flexible. You should actually start with prompt engineering rather than trying to fine tune a model. And only if that doesn't work, you should move on to sort of fine tuning. Function calling, you can sort of connect different kinds of tools and have structured outputs as well, like real-time information through function calling. So you can sort of improve your sort of ChatGPT, so the OpenAI sort of base tool. Other one is like, I think actually this is what you should look at, like embeddings and vector databases. Like you can sort of use a RAG system. So if you have like large data sets, you don't have to sort of fine tune it. And if it doesn't have a specific structure, you can use a RAG system. And then sort of at runtime, depending on the questions, you can sort of update the context with the right data set and then get the right result. Or you can use a hybrid approach like RAG prompt templates and a small fine-tuned model. So that depending on the use case, you can pick sort of a combination of that. So importantly, sometimes if it's a larger data set, like fine tune could be overkill. So you have to carefully pick and choose like when you do this. But there are like very specific use cases that you fine tuning works. Like image data sets for sure, fine tuning is a really good use case. For text, you have to pick and choose when to use fine tuning. Sometimes good prompt engineering should be sufficient with a bit of RAG. So this is the summary of it, like what we discussed, like fine tuning. We use fine tuning models to have specialization and to have like consistent sort of narrative style for OpenAI models or any kind of model, to be honest. And data quality is paramount. That drives performance. You should start small and iterate, like look at the results, the error rates, etc., to sort of tweak the data set and tweak the parameters of the training run and then sort of improve on it, and then write evals, right? Like you need a good regression testing, which is to test like if the prompt, if the model that you fine tune is good enough, whether it does the job or the previous one is better. So it needs to check if it is not hallucinating, like it's just messed up, like in some form. You need to check that. So you need to have spend a lot of time with the domain experts to create evals, so to check if the model is good enough. Sometimes fine tuning with RAG might be sufficient to get like good outcome. So yeah, you need to experiment with different kinds of sort of methods to get it done. I'm not saying fine tuning is the way to go. Like just know that's one of the tools in your arsenal. Like when you like do something in this space. Yeah, I think I just want to want to have like a few more minutes for questions. So that's why I want to like quickly go through the last couple of slides. So got like 8 minutes. If you guys have questions, happy to take them.
Or is it
Yeah,
only
yeah,
these?
yeah. You can. Yes, there are like so I don't know if you can do reasoning models, but like quite a few models. So if you go to let me see. So if you go here, I mean like yeah, I'll show here. I'll just stop this run because we don't need it now. So if you go to a fine-tuning model, so you can like select whether it's like direct preference optimization or reinforcement. You can pick here, and you can select the model. So you can look at all the models that are available. So that you can see the fine-tune models. You can fine-tune the fine-tune models if needed. 3.5, 4.0, 4.1. So these are the ones that are available right now. But
Right.
obviously not all three models at the moment.
Mm.
You see if I switch the model. Yeah, so if you go to reinforcement fine tuning, you can pick like, so the idea of reinforcement is like the LLM would check your answers and score it. Like so because of that you need to connect with a like a reasoning model to do that. Direct
Right.
preference optimization. So for different kind of methods, you have different kinds of models that you can pick and choose. Yeah.
How
Yeah,
will
I think you should be able to like. I haven't shared my models with anyone else, but I think you should be able to like there's I can't think of like a restriction around it where I think his
okay.
name is unique enough. Like so
Mm,
yeah, I think that's the case, but like yeah, I need to double check
mm,
to make sure. Yeah.
okay.
I think
Sure.
Gemini as well, like there's like yeah, most of the platforms provide this kind of service that can fine tune models. But also like you can do like open source models like on Hugging Face, you
Mm,
can use them to fine tune models, but you need to have your own cluster as well. But
right.
yeah, you have that.
So is
Yeah,
this on
yeah,
Java? Is it?
yeah. For these you don't have to. I think like
Okay.
if you take like that's a different kinds of fine tuning.
Mm, mm,
Yeah, I think like if
okay.
you use Hugging Face and you try to use them. Like you can use LoRa and stuff to sort of quantize that and sort of fine tune. Oh yeah, so I think yeah, you missed that slide. I think it obviously comes from sort of experience, like I think like playing around with it, but like general rule of thumb would be like so in the slides like I'll share them like for example SFT like for classification questions like if you have structured sort of input and output so expected outputs you can have that. Image ones obviously image problems and so direct optimization like so if you're like to get the model to like answer in a certain way like tone and style to be more human like so that would be like DPO and if it's like a very specific complex domain problem I'll go with like reinforcement fine-tuning RFT like medical diagnosis legal cases etc. So depends on the use case and also fine tuning is not always needed. Like you can use RAG and other kinds of methods as well. But like so yeah, I think like you need to like look at um the specific use case and pick and choose like how it sort of what's the best way. So definitely there are examples on each sort of training method so you can figure out easily what would be the best way to try like for your use case.
Oh, got it. Thank you.
Yeah.
That's
Yeah,
the
yeah.
weakness.
So exactly. So
Um,
it's in
yeah.
on their side as well. Yeah.
So
What do you
let's say
mean? What click?
uh,
Yeah, I don't know how it happens. So like
mm,
so they might store that data like as a data
mm,
set, and then depending on um how valuable the data set is, like the data point is, like not all the answers need like is
mm,
quality. So they might do like another filtration on that data set and sort of create like a massive data set and then use
mm,
that to fine tune later. So I think
right.
that's my assumption, but like yeah, I'm not exactly sure how they use them. I mean,
Okay. Okay.
obviously they'll sort of do a fine tuning run on your sort of specific model. Yeah,
Mm.
cool. Okay, I think we're good. Was there anything on the slides we missed? All right. Yeah. Yeah, do try it out. I think it's quite interesting. Like, I mean, there's other stuff on Hugging Face. Fine tuning. There's an entire sort of like section on fine tuning. Do check it out. Like, so how you can sort of use um, open source models and like how to fine tune them. This is much more fun than what OpenAI provides because you're just stuck with OpenAI models there. But here there are different kinds of models, different variations, like so open source models. And I think Grok was open sourced. I think yesterday. Let me see if that is the case. Not sure. Let me see. Maybe I just saw it. Wait. Yeah, I think there's Grok 2 is there now. I think yes. So yeah, so it's quite new. So now you have Grok 2. You probably need like a bigger GPU to test this, but yeah, Grok 2 is there, and like I think in 6 months they're gonna open source Grok 3. So we can do quite a lot of optimizations around this. Yeah, just a very small number of people download the model. So yeah, that's it about the fine tuning. I think